What if I told you that inside your body right now, two fist-sized organs are filtering your entire blood supply every single minute? They meticulously remove waste. They balance critical minerals like salt and potassium. They control the fluid levels that keep you from getting puffy or dehydrated. They even help regulate your blood pressure, signal your bones to make new red blood cells, and keep your body's internal chemistry so perfectly stable that you can stay alive. These unsung heroes are your kidneys. And even though most of us barely give them a second thought, your kidneys are working 24 hours a day, 7 days a week, like a microscopic, hyper-intelligent water treatment plant built right into your body. They are the silent guardians of your inner world. Today, we're shrinking down to a microscopic scale and taking a journey deep inside one of these incredible organs. We're going inside your kidneys. Your two kidneys sit deep in your abdomen, tucked safely in your back, just below the bottom of your rib cage. You could hold one in the palm of your hand. Each is only about the size of a computer mouse or your own fist. But don't let their small size fool you into thinking their job is small. These compact powerhouses are incredibly efficient. Together, they process a staggering amount of fluid, roughly 180 liters every single day. To put that in perspective, that's more fluid than would fit in a standard bathtub, and they filter all of it every 24 hours. Now, that obviously doesn't mean you urinate 180 liters. If you did, you'd be spending your entire life in the bathroom. The genius of the kidneys isn't just in filtering, but in reclaiming. Most of that fluid, over 99% of it, is carefully and precisely reabsorbed back into your body, carrying with it all the good stuff you need. Only the true excess, about 1 to 2 liters of concentrated waste and extra water, usually leaves the body as urine. It's a system of incredible efficiency. Filter everything, reclaim what's vital, and discard the rest. Our journey begins where the blood does, the renal artery. Imagine this as a massive, pulsing highway carrying blood directly from the heart, branching off the body's main artery, the aorta, and plunging straight into the heart of the kidney. As we follow this vessel inside, we see it split again and again, branching into smaller and smaller vessels, like a tree spreading its roots through the soil. The passages get narrower, the flow more controlled, until we arrive at the kidney's true functional units. These are the places where all the action happens. We've arrived at the nephron. Each of your kidneys contains about 1 million of these microscopic filtration machines. That's 2 million nephrons in total, all working in parallel. They are the tiny engines that drive the entire operation, the real workers on the factory floor. And our next stop is the very first station on the nephrons assembly line. At the head of every single one of those million nephrons is a tiny tangled ball of capillaries called the glomerulus. The best way to think of it is like a high-pressure biological coffee filter. Blood from the renal artery is forced into this little network of vessels at a high pressure. This pressure squeezes the liquid part of the blood through the filter's microscopic pores. Small molecules pass through easily. Water, salts, glucose, amino acids, and waste products like urea all get pushed through into the next part of the nephron. But the larger, more important things are held back. Red blood cells, white blood cells, platelets, and large proteins like albumin, they're all too big to fit through the gaps. They stay behind in the bloodstream, continuing their circulation through the body. This first, raw filtration step creates a fluid called, appropriately, filtrate. But at this point, the filtrate is a mixed bag. It contains all the waste products we want to get rid of, but it also contains huge amounts of water, salt, and nutrients that the body absolutely cannot afford to lose. So the kidney's next, and perhaps most brilliant job, is to decide exactly what to keep and what to throw away. The kidney doesn't just filter, it chooses. From the glomerulus, the filtrate now flows into a long, twisting U-shaped tube called the renal tubule. This is where the real magic happens. This tubule is not just a simple pipe, it's an incredibly intelligent sorting and reclamation center. As the filtrate flows through its winding path, the cells lining the tubule are constantly making decisions. They see glucose, the body's primary fuel, and under normal circumstances, they pull all of it back into the blood. They see essential minerals like sodium, potassium, and calcium, and they carefully adjust how much to reabsorb based on the body's immediate needs. If you've just eaten a salty bag of chips, the tubules will let more salt pass into the urine. If you're low on potassium, they'll reclaim more of it. And then there's water. The tubule's handling of water is a masterclass in adaptation. If you're dehydrated after a long run, your brain releases a hormone that tells the tubules to become like a sponge, reabsorbing as much water as possible to conserve it. The result is a small amount of dark, concentrated urine, but if you've just downed a liter of water, that hormonal signal is switched off, the tubules become less permeable, and more water is allowed to flow through, resulting in clear, diluted urine. All the while, the waste products, the urea and creatinine, are largely ignored, left behind in the tubule to be sent on their way to the bladder. This is homeostasis in action. Your kidneys are constantly adjusting, second by second, to keep your internal environment perfectly stable, no matter what's happening outside. But the kidney's role as master chemists doesn't stop there. They are also crucial regulators of one of the body's most important metrics, blood pressure. Your kidneys are equipped with sophisticated sensors that constantly monitor the pressure of the blood flowing into them. If these sensors detect a drop in pressure, perhaps because you're dehydrated or have lost blood, they immediately sound an alarm. They release an enzyme called renin into the bloodstream. Renin kicks off a complex hormonal chain reaction known as the renin-angiotensin-aldosterone system. It's a mouthful, but its effects are simple and powerful. This system causes blood vessels throughout your body to tighten up or constrict, which instantly raises blood pressure. It also signals your body to hold on to more salt and water, which increases the volume of blood in your system, further raising pressure. It's a brilliant survival mechanism. But it also highlights why kidney health and blood pressure are so deeply connected. It's a two-way street of potential damage. Uncontrolled high blood pressure can scar and damage the delicate glomeruli in the kidneys over time. And in turn, when the kidneys are damaged, they can't regulate blood pressure properly, often making it even worse. Every single day, your body's normal metabolic processes create waste. When you eat protein, the breakdown process creates a nitrogen-based waste product called urea. When your muscles work and repair themselves, they create a byproduct called creatinine. On top of that, your bloodstream carries medications you take, toxins you might ingest, and all sorts of other metabolic byproducts. If these substances were allowed to build up, they would become toxic, poisoning your system from the inside out. Your kidneys are the primary route of removal. They diligently filter these substances out of the blood and ensure they are safely excreted in urine before they can accumulate to dangerous levels. This is why a decline in kidney function is so insidious. When the kidneys slowly start to fail, they become less efficient at clearing these wastes. But the body is resilient, and for a long time, there might be no outward signs. The waste levels can creep up slowly, over months or even years. This is why kidney disease is often called a silent killer. Significant damage can occur long before any symptoms appear. So what causes this silent damage? The two biggest culprits behind chronic kidney disease are high blood pressure and diabetes. They are a devastating one-two punch for kidney health. High blood sugar from uncontrolled diabetes acts almost like a sticky poison to the tiny blood vessels inside the kidney. Over time, the excess sugar can damage the delicate walls of the glomeruli, making them leaky and less effective. High blood pressure, on the other hand, is a physical force. It's like running a delicate engine at a constant red line. The relentless pressure batters the fragile filtration system, causing scarring and injury that accumulates over the years. Other major risk factors include smoking, which reduces blood flow to the kidneys, Obesity, a family history of kidney disease, and the overuse of certain medications, like some over-the-counter painkillers. The truly scary part is that you can lose a significant amount of kidney function without feeling a single thing. You don't feel the tiny filters getting scarred. You don't feel the creatinine levels slowly rising in your blood. That's why awareness and prevention are so critical. Regular checks of your blood pressure, your blood sugar, and simple blood and urine tests to check for protein and filtration rates are the only ways to catch damage early. So, as our journey comes to an end, what have we seen? We've seen blood enter a fist-sized organ where it's forced through millions of microscopic filters. We've watched as a sophisticated system of tubules reclaims precisely what the body needs, moment by moment. We've seen extra fluid and waste products collected and sent on their way to become urine. And behind all of that, we've learned that the kidneys are also controlling blood pressure, balancing minerals, managing your body's acidity, and even helping to produce red blood cells. Your kidneys are not just filters. They are chemical engineers. They are pressure sensors. They are hormone regulators. They are the silent, tireless guardians of your body's internal balance. The best way to protect them is simple, but not always easy. Manage your blood pressure, control your blood sugar, stay hydrated, avoid smoking, use medications as directed, and get regular health checks. Because your kidneys may work in silence, but they are working every single second of every single day to keep you alive. If you enjoyed this journey inside the human body, subscribe to CellWise Health for more science-backed health education.